Apparently the snow's supposed to stop though by later on today.
Yeah, but it keeps moving north. Like originally, this whole storm was supposed to miss us to the south. We were supposed to get, not that much, but then everything
Mhm.
went north. So, and then who knows what'll happen with lake effect. But whatever happens, happens. Doesn't matter. I think for Wisconsin, you know, 5 or 6 inches of snow up to a foot of snow is kind of the same thing. We're pretty good at getting it removed. So, you're probably 3 or 4 hours away from whenever it stops, having everything mostly drivable, except for digging your car out. Okay, everybody can see the slides here. And this is 300, right? This is the right class.
Yep.
All right, so let's start talking about logistics, and then we'll start talking about what we're going to do in here and all that jazz. Grading for the class, pretty similar to what you've had before. 10% Bible homework, 50% programming assignments. These could have some other kinds of assignments written and stuff like that, but a majority of them will be programming assignments. 20% midterm, 20% final. Again, with the policy that if you do better on the final exam than you did on the midterm, I'll replace your midterm exam score with whatever you got on the final. Now, a little change that we're making, that I'm making this semester is part of this is because of kind of COVID scheduling and people being online. So things got forgotten quite a bit last semester in terms of a lot of people were turning in Bible homework late and stuff. And that's fine. I mean, I graded it. It wasn't the end of the world. But what I did was I put up 3 total Bible homeworks. They're to read 3 books of the Bible, 1st, 2nd, 3rd John, and write like a response kind of paper to it. It's like a 1-page thing. So probably, in total about the same amount of writing as you would have written for the normal Bible homework I gave. I made all of these due by the Friday of finals week. So you can decide when it works for your schedule. My encouragement to you would be set up a reading schedule where you're reading, once or twice a week for the duration of the semester. That was the original intention of the assignments, is to kind of get you into the habit of reading the Bible. So if I had my druthers, you would set up your own little schedule for your Bible readings, and then roughly a third of the way through the semester, do the first assignment, so on and so forth, something along those lines. But manage your own time. All 3 of those are due by Friday of finals week by, I don't know, midnight or something like that. So just make sure you don't turn those in late. All right. Any questions about the change in Bible homework? Okay, so that should lead to less panicked emails on Monday morning that you forgot to turn in your Bible homework or stuff like that. Other stuff should be pretty normal to you. Class meetings. So we will meet face-to-face every class meeting except for today. First class meetings are online. So, barring illness and stuff like that, which, cross my fingers. Luckily, pretty much the entire break, I didn't have any illnesses. So hopefully we're back to the races with, my historical perfect health. But, so classes will meet face-to-face. I'll also be online for every class. So I'll always start a Zoom session. I'll always record it. I don't care which format you attend class in. I guess the generic suggestion would be, I encourage you to attend face-to-face, but if that's not the right fit for you for whatever reason, that's fine. Based on the responses I got for people that felt strongly about coming face-to-face and wanted to kind of reserve a seat, and based on the experience from last semester with the number of people that would actually show up to class, I think that if you want to come to class face-to-face, we will have space. If you want to be online, feel free to stay online. we'll revisit that if it becomes a problem. So all of you that emailed me saying you definitely want to be face-to-face, I don't think we'll have a problem accommodating the seats. I guess worst case scenario, if everybody decides to show up face-to-face, we'll burn that bridge when we get to it. But I think we should be good. We're no more than kind of half the class is showing up face-to-face because they choose to be online. The one challenge I'll throw out there, and a couple of you have already reached out to at the end of last semester, is don't just take the class online because it's more convenient. I know it might seem more convenient, but if you be honest with yourself in terms of whether that's your best mode for learning or whether the class falls off your radar, things like that. So do what's best for your learning, not necessarily what's best for your schedule. That would be my challenge. So if you go online, do it for the right reasons. Okay, I believe is the class scheduled for S109, correct? I think that's or are we 118B? I don't remember which of the two classrooms. I think they're roughly the same, but I think our classroom capacity is right around like 16 or 16 students or something like that. So I think we'll probably be fine based on the number of people that showed up face-to-face last semester and stuff. Okay, so in here, in this class, we're going to be using...
What room is this in again? This is 118B?
I don't remember which one it was scheduled for. It's either S109 or S118B. Does anybody have it in front of them?
I'm pretty sure.
118B?
Yes.
Okay.
Yeah, it's 118.
Yeah, that's the room right next to the Mac lab in computer science. Okay, so...
Because I know last semester, I think we were scheduled there, but then there was like a conflict or something.
Right, that was with
250.
Dr. Locklear's class. So we'll figure it out. But you know, if they presumably there should not be a conflict. I think that was a mistake that the registrar had made. Presumably there should not be a conflict in classrooms, but we'll figure that out on Thursday when we have class. All right, so what are we doing this semester? So we're kind of accomplishing several things. We're going to be dealing with something called data structures in here. We are going to be using the C++ programming language. We are going to be using Ubuntu Linux for our coding. If you want to use a different flavor of Linux, you can, but I'll be doing all examples using Ubuntu, which is kind of the, let's call it the most user-friendly Linux. Let me switch over to this here. So if you go to ubuntu.com, this gets you to the Linux page. You can go to download, and there should be tutorials and stuff. I would
We can run that through a virtual machine, right?
Yeah, I'm going to talk about the whole thing. I'll talk about the different options here in a second. So the one that I would suggest is the Ubuntu Desktop 20. So this is the latest version that they fully support. So this guy right here. And then you can follow tutorials and stuff like that for installing it. Now, options for installing it. Let's see, where's my... All right, so you can put a virtual machine on your own computer. So like, for instance, VirtualBox or something like that. VirtualBox, VMware, Fusion, VMware Fusion for the Mac, Parallels for the Mac, but VirtualBox is free, and that's an Oracle product. So you can install that on your computer, and that will allow you to kind of share your computing resources. So that's what I do. I use Parallels for the Mac, and I have Ubuntu running on my Mac at the same time as the Mac OS is running it. It's just using some of my processing power, some of my memory, things like that. So if you have a computer with quite a bit of RAM and and a pretty decent processor and things like that in it. Running this as a virtual machine could make some pretty decent sense. It probably wouldn't slow your computer down too much. If you have a very, very, very old computer, that might be a little bit more sketch. One nice thing about Linux is it does require significantly less system resources than Windows does. So, even if your computer has, let's say, 8 gigabytes of RAM or something like that, which is not a ton of RAM, but not, horrible, you might still be able to pull this off running VirtualBox and have it be fast enough to kind of get your homework done and that kind of stuff. The other thing you could do is you could install it on your computer by dual booting, which then, you would just restart your computer and boot into Ubuntu. So it's getting all of your computer system resources, and you would just use a portion of your computer's hard drive to hold that. There'll be tutorials and stuff like that online. Another option, and this is an option that'll be pretty much only available to students who are living on campus who are willing to come to campus when they want to do their homework, that's to use our new VM server in computer science to create this. And just to kind of give you an idea what this looks like. So in computer science, there is a new, you get within proximity of the department, there is a new CUWCS Wi-Fi, and the password is that. All right, so 0 through 9. That'll get you on the CUWCS Wi-Fi. Now, this wireless connection is different than FalconNet. So there will be some resources on campus that you may not be able to reach if you're on the CUWCS Wi-Fi. You basically have internet action. You basically have internet access from CUWCS Wi-Fi, but you don't have access to any of the other resources on campus, like if you have to access any sort of SharePoint stuff for any of your classes or something with, you can access Banner on the web, but anything that you can access off campus, you would be able to access from there. But if you need something that you only can access when you're on campus, you might not be able to access it from this Wi-Fi. This is a new network that IT created for us that segregates computer science from the rest of the campus network, so we can do some stuff in our networking classes and security classes that are good for us for learning, but might be damaging to the rest of the computer network if we're pretending to do hacks and stuff like that. So that's the purpose of this Wi-Fi network. So that's the password for that guy. Now, what does our network currently look like? I'm not going to go into the tons and tons of details with it, but I'll kind of give you an idea of what we have sitting in there. So we have a VM server. And this guy has 384 gigabytes of RAM, and it has, I want to make it taller, 96 CPUs. So lots of RAM, lots of CPUs. I'm going to do a tutorial on how you can create your Ubuntu install using that on class on Thursday. The reason I'm not doing it now is I'm at home right now, so I don't have access to it. So in any case, that is a server that's there that you would hit through a website and launch a virtual machine. You would first create your virtual machine and probably put your name on it. So nobody else accesses that virtual machine. And then whenever you need to do your homework or something, or you're in class and you want to bring up your virtual machine, you go through this website, you spin up your virtual machine, and then you can use it on your computer, kind of like streaming, like you're on a web page. If any of you have ever used TeamViewer or VNC Viewer, those are things that kind of, you're not using your computer's resources, but you are using your internet connection to remote into this computer that you can use. All right. I know some of you kind of did something along those lines when you had the Raspberry Pis in the 200 class you took, and you used VNC to remote into your Raspberry Pi from your computer. So it would be a pretty similar thing to do that, but instead of the operating system living on your Raspberry Pi, your operating system runs on this VM server, that virtual machine server that lives in computer science. So you wouldn't have to install anything on your computer special in order to access this. Now, all these things, just to kind of give you the rest of the network layout here. So this whole thing lives behind CUWCS Wi-Fi. So the only way you can get to this thing is if you're on the CUWCS Wi-Fi, or if you're physically in that room and plugged into one of the physical ports on the router. So if you're in any networking classes or the security class and you go in there, you can, you'll be doing some stuff where you might bring your laptop in and connect directly to the network through Ethernet. But generally speaking, the way you will get to these resources is by getting on the CUWCS Wi-Fi. And the only way to get on the CUWCS Wi-Fi is to be in physical proximity to the department. So in one of our classrooms or the Mac lab, something like that. So then the natural follow-up question might be, well, what if I live on campus and I want to be able to do my homework? And I want to be able to store my virtual machine on your virtual machine server, but I want to be able to do my homework from my dorm room. It's possible, but I can't necessarily guarantee it's going to work all the time. And let me kind of explain why. The idea here would be is you would create your virtual machine. So I'm going to say Mike's VM. All right, so there's my virtual machine that I've created, and it lives on that VM server. All right, now I don't have to shut down my virtual machine when I'm done using it. Now, realistically, you probably want to, because that virtual machine, as long as it's running, is using some of these resources. But more importantly, this machine manages those resources on its own. So even if you don't do anything special, there's a chance the virtual machine server will pause your virtual machine, kind of taking it offline, but allowing it, kind of like shutting the screen of your laptop where your computer goes to sleep. And when you reopen it, it just picks up where you left off. So it's possible that the virtual machine server will put your virtual machine to sleep to make sure it has enough resources for the other people who are actively using it. Now, one thing you might do if you want to use this from your dorm room is you might install on here VNC server. So you might install VNC server on your virtual machine. And then you could have your laptop or whatever in dorm room. Or anywhere else on campus, the library, something like that. Somewhere not on CUWCS Wi-Fi. And you would install VNC viewer on here, which allows you to talk to a VNC server. Now, I'm actually going to say this is real VNC, and this is real, kind of like a brand of VNC. And the reason why I'm suggesting that particular brand is
it's like one of those programs all those scammers use, right? Kind of similar.
No, VNC is like TeamViewer, allows you to remote into
So I'm
another.
saying like the scammers always use like TeamViewer to connect people's computers.
Well, I guess, but I mean, it has. I wouldn't associate it with software that scammers use. Like, I mean, it's something that's very.
Oh, no, I know it's legitimate. I'm just saying
Yeah.
that like scammers don't use legitimate software to scam people.
Well, sure. So I mean, I guess that's reasonable, but I mean, it's. I would say it's mostly legitimate. I don't think like BitTorrent might be something that you say, well, most people who use BitTorrent are using it to download illegal software. I think most people who use TeamViewer or VNC are not using it to break into people's computers. They're using it for like managing a computer or fixing it from remotely, that kind of stuff. Now, Real VNC, the reason I suggest this is they have a cloud. So Real VNC cloud. And the idea here is that if you have VNC server running on your virtual machine, it will connect to the cloud with your account. You could have up to 5 with your Real VNC account. You can have up to 5 computers running VNC server and having access to them from your VNC client.
I have a question.
Go ahead.
Would your virtual machine be running Real VNC server like at all times?
That's I'm in the middle of explaining that right now.
Okay.
All right, so here's the situation. I said this probably would work. Well, this might work some of the time. Because the idea is as long as this virtual machine is running, Real VNC software that's running on that machine would be running and would connect to the Real VNC cloud, which will allow your laptop in your dorm room to also connect to the Real VNC cloud and allow you to access this machine. Okay, but that's only if the virtual machine server hasn't decided to put your virtual machine to sleep. If that happens, then from your dorm room or from off campus or wherever you are, you would be with your viewer, you'd be able to reach VNC's cloud, but VNC's cloud would not have a connection to your virtual machine for you to reach that. So this is something you'd have to experiment with as the semester goes on based on the usage that the VM server is getting, because even though you might choose not to put your virtual machine to sleep when you log off, the VM server might put it to sleep if it needs additional system resources and there isn't any activity on your virtual machine right now. All right, so the idea would be is if this is on, then this will work. But if this is off, you won't be able to reach it remotely. You would have to be on the CUWCS Wi-Fi where you could go in and start your virtual machine, wake it up through the Wi-Fi, because actually what runs on here is a product called vSphere, or vCenter rather. Actually, I think it's vSphere and vCenter. So this is a piece of software that manages this hardware to allow you to configure virtual machines. So once you configure your virtual machine once, you won't have to do it again. That will be your virtual machine. You'll put your name on it or your phone number, whatever, however you want to uniquely identify it. And then, once I demo this next class, you'll kind of see how it works. It's not real difficult, but it will require a level of trust, because I don't want one of you to go on and launch somebody else's virtual machine. Now, you might not be able to get into their virtual machine because you wouldn't have the password, because they're probably going to set up their own password for it. But bottom line is that each of these virtual machines should be kind of independent for the student who's going to be using it. And the idea would be is this is kind of like your computer in the cloud hosted in the department, so that you don't need to run it on your own system resources. but the side effect is that you will be limited on where you can access it. All right, so if you live on campus and at the very least you're willing to come near the CS department to work on your homework in the event that this VNC server thing isn't working. Now, one thing you could do is, and this is to the question before, is let's say you're in your dorm room and you can't reach your VNC server because it's gone to sleep. Well, you could walk down to computer science, launch your virtual machine, and then go back to your dorm room and hit it by VNC and probably be fine for the rest of the night. Okay, so I suppose in the reality, sometimes if it's not listening, you might just need to walk down to computer science, get on the CUWCS Wi-Fi, log into vCenter through the website, wake up your virtual machine, and then you'd be able to reach it from VNC from your dorm room. Okay, I know this seems maybe a little bit complicated, but remember the punchline here is that you have lots of options on how you can do Ubuntu for you. All right. If it were me and I had a computer with plenty of system resources and things like that, I would just install it as a virtual machine on my computer so I can run it and I don't have to worry about it being hosted on campus or anything like that. But if you don't have a situation compatible with that, you have some other options. So everybody in here should be able to use get Ubuntu Linux working. And like I said, I'll demo next class how to actually install Ubuntu on the virtual machine server. We already have the ISO up there and everything. So you would literally follow the thing I did, I'll do in class next time identically for your particular virtual machine, and then it would just be up there. All right, so that's kind of an intro to what we have going on here in the new room. Inside this room, we also have a new networking and security sandbox. In S109, we have a new robotics and AI lab as well that talks to this. So we have some new high-end 17-inch laptops that are all running NVIDIA 2060 GPUs. So in the back of S109, that might be a good place to come and work, do study groups or something like that. And if you don't have a laptop or you don't have a good machine, you can always do your sit at one of the 17-inch laptops and do your homework from that. It'll be utilized in the robotics and artificial intelligence classes with the CPU power and the GPUs for those laptops. We'll also use it for some VR stuff. So it'll serve multiple purposes. But that lab in the back of S109 is configurable. So all the machines are on like wheelable carts with gaming chairs that are around them. So you can kind of configure it however you want. You could put it in a circle if you're working in a study group. If you were just working alone in there and you want to pull one of them off to kind of the side so you're segregated from the other ones, you can do that. So that's one of the new things we have in the back of S109 that you can go and check out. And we'll be getting the rest of the details to you about that probably this week, if not early next week, for like passwords and stuff like that. But you know, these are all resources that we encourage you to use. One of the issues we had last semester is we had students who wanted to work in a study group, but they only had a desktop computer. And you know, with Zoom that works out okay, but if you're going to meet in person or something, it ends up being limiting because you don't have a computer and you're sitting there just taking notes. So hopefully that's not the case now. So give me some feedback as you start taking advantage of some of these resources. I want to know what works, what doesn't work, what should change, because ultimately I want to have it be the best experience for you, but we have added some new things. Another cool thing that we don't quite have in 109 yet, but we already have the thing and we're testing it. We're going to do some more stuff with VR this semester in the department. We have some UV sanitizers that you can put the whole VR headset in between uses, and that'll kill off any germs or whatever, because, you know, obviously we are hypersensitive to COVID and things like that now. So it should be safe to use. But we also have a new VR chair that you sit in, and when you turn your head and stuff, the chair moves, and you can actually do locomotion by walking using these foot pedals on the chair. So That'll be some other cool stuff that you can use to experiment with the latest, greatest technology. So once I have that on campus, maybe we'll do a demo day or something like that. But so some new things that are happening. And then a past announcement that I'll make again is keep in mind that all of you have unlimited access to the makerspace. And now we spread the printers around. So some of the printers are in the back of S109. Some of them are in the makerspace down in the business building. Some of them are upstairs at the business building. And the plastic for printing is free for all computer science majors. So we encourage you to experiment with that, learn how 3D printers work if you haven't done that before. We have several students working in the makerspace who can certainly give you a tutorial. But we want you using those types of things. We also have 2 laser cutters in the department that you are also welcome to use after you've been trained on them. So in any case, take advantage of the resources and things like that. But from this class's perspective, this is the piece that is might be of interest to you depending on how you choose to get Linux onto your computer. All right, questions about any of that? And like I said, I'll give a demo of how to actually create your virtual machine on this next class when I'm on campus and can connect to the CUWCS Wi-Fi. All right. So let's talk about C++. So this semester, before this semester, and let's kind of go back to, I'm going to draw our little chart that we've had before. So we have the C programming language, and a couple of you I think are in the 450 class this semester and you're going to be doing C programming in there. C++. So this was a procedural language. This is the first, let's call it popular object-oriented language. It wasn't the actual first object-oriented language, but it was the first popular one. So we had Java. Off of Java, we had C#. All right. And I would think most of you, let's see, actually, most of you are taking software engineering this semester. Is that accurate?
Yeah.
Okay. Yeah, because we had it scheduled weird from last semester because of the start of the new program. So in the software engineering class this semester, you'll likely be working in C#. I think Dr. Locklear does .NET development with C#. But keep in mind that class is it's not all a programming class, even though it sounds like it would be. It's mostly a working in groups, collaboration on large software project class with some programming. So the skill of software engineering has less to do with the actual writing of the code, and more to do with the planning process that leads up to ultimately writing the code. In fact, I maybe have mentioned it in one of the classes before. Some of the software development tools, software engineering tools that exist today are such that if you design, you do the planning process at such a detailed level, it'll actually generate a whole bunch of code for you. So it actually reduces the amount of code you actually have to write. So that's how important that planning process is when you deal with larger and larger projects, especially when you have multiple developers all collaborating on them. All right, so that's something you should look forward to in the software engineering class. Don't view it as a programming class. It's not that programming is absent from the class, but the real skill in that class is how do I work in a team of software developers on a big project? And that's going to be the reality for most of you once you get into industry and work a job. I mean, some of you might be working in your own little projects, but more than likely you're going to be using collaboration tools like GitHub and things like that. We'll look at some of those things here in a few minutes as well. Okay, so So you'll be probably doing some C# stuff with Visual Studio in there. So Visual Studio is kind of like Eclipse and Android Studio that we've used for Java. For C++, if you're on a Windows machine, you might use Visual Studio to use Visual C++. We're not. We're going to be on Ubuntu, and I'm actually going to just use Visual Studio Code, which is just a text editor to write our C++ code in there. And I'll make connections back to Java so we see how things work. If I go back to this screen here, one of the nice things, I would say historically, I appreciated learning the languages in a different order. So for instance, I started off writing in C when I was like maybe nine years old or so. That was just my hobby, let's say. It was just a weird kid. So I started off in kind of an older, more cryptic language, then got into C++, doing object-oriented stuff. I started writing in Java when Java first came out. But one of the nice things is it allowed me to really appreciate some of the things Java hides from you. But you know that those things are there. So if you think back to last semester and some of the stuff like in Java, if you are doing inheritance, well, technically extends object is an invisible thing that's there for every one of your Java classes, but you don't have to write it. Because it's assumed to be there if you're creating a class and you don't specify that it inherits from any other class. And there's some other things that are similar to that idea. Now, if you had already been coding in an older language, like these, where some of those things weren't hidden from you, you maybe appreciated Java's help there. Kind of makes life a little easier by having it automated. Kind of like these new cars now. Like my car has the brights come on automatically. So whenever I'm driving at night, whether I think I need the brights or not, they flick on as long as it's not going to hurt another driver who's coming at me. So it keeps track of that stuff. So it's something that I now have become accustomed to, where I always can see better at night as long as there aren't cars coming at me. But I can appreciate that because historically, if I ever thought I needed the brights, I had to flick them on manually, something like that. Whereas for you guys, presuming you didn't have programming prior to 200, you kind of jumped into more modern technology like Java or Python, where some of these things are being hidden, but you didn't know they're being hidden because you didn't know that they were there to begin with. All right, so I'll reveal some of that stuff, and I know I've done it before as well in class, but those are some things we will talk about. So kind of keep in mind that we are almost taking a step backwards in time by going from Java to C++. Now, having said that, C++ is still a very popular language. If you look at the jobs available in the computer science industry, your primary programming languages are going to be C++, Java, C#, and Python. Those four languages are probably will make up a bulk of the languages you would be working in the industry. Not that other ones aren't founded. C would be used in a lot of embedded things. If you're writing software for dishwashers and stuff like that, you would be using C for that type of stuff. But again, programming is the skill set. The language doesn't really matter. So that really hasn't changed. And all of these languages are based off of C anyway. So it's not like you're going to see drastic syntax changes this semester, but just the little ways things are done in C++ compared to Java. Those nuances we'll be learning, but it's very much an industry standard language that's important. So this is a skill that will benefit you, and you'll be able to put it on your resume as a, hey, this is a skill I know type thing. All right, so that's where we're fitting in here. Other jobs that might exist out there would probably be, if you just kind of do the same, this is Objective-C on the Mac side, and then Swift on the Mac side. So basically, you'd only live over, you'd only live over here if you were doing, you know, we'll say Apple programming, but at the end of the day, it's really iOS programming. I think a very high percentage of people that are working in these languages are writing stuff for iPhone or iPad, not necessarily writing stuff for the Mac. Not that there aren't people who write software for the Mac App Store, but the Mac App Store, I think, is significantly less popular than the iPhone App Store. So this would be your special case. This is the iPhone language, which certainly you'll find plenty of jobs doing that. But I would say a huge swath of the jobs in industry will be using C++, Java, C#, and Python. All right, questions about kind of where we're going to be fitting in terms of the technology we're using this semester. Okie dokie. So let's go over, let's see, I don't think I need to do the GitHub tutorial yet. Well, we'll see if we bump into it today. But let's start off with hello world I'm going to start with C. Okay, because what we want to do is we want to see the evolution from C to C++. All right, we always start off with our hello world. One thing you're going to notice this semester, and there'll be things where I have to look them up because sometimes certain libraries in C and C++ have been around for so long. Sometimes certain older libraries that I might have been used to are starting to disappear, be deprecated, and replaced with some newer things. But you'll find pretty quickly that all the stuff makes pretty good sense once you kind of get used to it. And just like learning how to read the Java documentation, you'll be able to get into it as a pattern pretty quickly. All right, so we're gonna go over here, and I'm just going to, I created a new folder. Didn't I create a folder first? Oh, I created this 450 folder. I want to create another folder here. So we'll call this guy CSC300 Spring 2021. Drop this down here. Okay, so there's that folder. And like I said, I'm using Visual Studio Code here. If you go to code.visualstudio.com and you go to download, well, actually, it'll show it to you right here. For Ubuntu, you want the Debian package here. See, it mentions Ubuntu here. Download that. When you double click on it, it'll install it. And then you'll get an icon. I think it puts the icon there by default. If it doesn't, I think it's VS Code. Trying to think what the launch thing for it is. And you can see you can get it for all the different packages. Let me just do a search real quick for Visual Studio Code Ubuntu command. That's installing it. Yeah, it looks like it's just called code. Yeah, it's just code from the command line. All right, so you'll see me run that plenty of times, but as you're getting it set up, and I'll actually do it when we on Thursday. In fact, let me put a note in the slides just so I don't forget, so you get your full setup. Install Ubuntu Thursday. Install VS Code as VS Code and VNC server for demo. So we'll spend some time on Thursday going through that whole process of getting your virtual machine installed, getting Visual Studio Code on there, and putting VNC server on there, and then I'll show you how to use the VNC server from on campus by using VNC client to reach it. All right, so we'll cover that full thing to allow you to take advantage of this from your, somewhere else on campus or at home or whatever.
I have like a question for clarification.
Sure.
VNC client the same as VNC viewer?
Yes. Yeah. VNC viewer is the client for VNC technology. Specifically, you want to use real VNC. Some of the other ones might have cloud as well, but real VNC, that brand, has their own cloud that lets you do up to 5 computers. But yes, when I say client, I'm talking about VNC viewer.
Sounds good. Thank you very much.
All right. So in any case, we'll be using Visual Studio Code in here. And what I'm going to do is we're going to start off. I'm going to create a new file inside this folder. And we're going to call this guy hello world.c. All right. So we're going to write a C program initially. So we want to kind of see how this guy has evolved over time. All right, so we're going to say include standard IO.h. So this is standard input output. We have something called a header file. So let's talk about header files. First of all, remind me, what is MVC?
Model view controller.
Okay, and what's the purpose of model view controller? What kind of animal is model view controller, and what does model view controller tell us?
It tells you like how to separate the different pieces of a program so they don't go together.
So this guy's a design pattern, which says that it is a good idea to keep your code separate from your interface, separate from your data. That's the concept behind MVC. Now, as a Java programmer, to my knowledge, this doesn't necessarily have a name, but as a Java programmer, when we write a class, we have all of our code and implementation in a single file. Now, last semester, we talked about these things called interfaces. Anybody remember what an interface is? We would have talked about it. It probably would have been near the end of the semester with talking about it with threads and things like that. So an interface is a collection of fields and functions that must be written by implementing classes. This is a way to describe the features a class must have without actually implementing those features. All right, so specifically last semester, our example is we had an interface called runnable. And the thread class implemented runnable one end or two ends, I don't remember. Implemented runnable by having a public void run method that did nothing. We would inherit from the thread class and override that run method with our own logic for what we wanted to happen when the thread started. All right, but the important thing here is let's just go on to the next slide. Why is this important? We had a single file, in this case, runnable, that listed the features of what all runnables will have without hundreds of lines of implementation getting in the way. Think of this like built-in documentation. So last semester, we would go and look at the Java documentation. It just gave us a list of all the functions, whether they were static or non-static, what they returned, and maybe a little blurb of what they did, but we didn't see all the code that went into implementing them when we looked at the documentation. So it was convenient to say, oh, I'm dealing with a string. What can strings do? All right, so if I go in here and I say string Java documentation, we scroll down here, we see here's all the methods that strings can do. They have a char@, method that takes an int index. This is what it does. This is what it returns, but we don't see all the code that goes into char@. So we can think of this as kind of like an interface that is at a glance, I can kind of flip through here and see all the things a string can do. Okay. But as a Java developer, typically we would write one of our one-off classes. Now, keep in mind that an interface like runnable was written as an interface because they said all classes that want to be runnable must implement these methods, for example. So it's a way of kind of forcing your classes to adhere to a standard, as opposed to if you were just creating a one-off class to do something. You're creating a person class, for example. You might, well, if you're creating a person class, that's not something you would create interfaces and things like that for. Instead, you would just have all your code inside of person.java. So you would not only have the list of methods and the list of fields, you would also have the implementation in there. And if it was complex enough, you might have hundreds of lines of code that you would have to scroll through to go and see what how you implemented a certain method or what the return type for a method is or something like that. So it's not necessarily that convenient. So in my opinion, I would say we've kind of moved away from something that was popular in the C and C++ time period. But it has sort of kind of been replaced. So let me go show where am I at. So what's a header file? In C and C++, a header file is is kind of like an interface that a .c or .cpp file implements with all of the methods described in the header file. Think of this like built-in documentation. So on one hand, we can say this is a bit inconvenient in that we have to create 2 files for every one class we want to implement. And we could just say, generally speaking. You're going to see here in a minute, we're not going to have to create 2 classes because we're not going to be writing objects initially. But I think this is a fair statement to say we would, this is inconvenient because if we want to create a person class in C++, we have to create 2 different files. So, for example, if we wanted to create a person class in C++, we would create a person.hpp. Okay, this is a C++ header file. And we would create a person.cpp. This is a C++ implementation file. This is where we describe what a person will contain. This is where we actually implement the logic. Now, we would say we do not do this in Java. Why don't we do this in Java? Any ideas?
Does it have something to do with it's an object-oriented language?
C++ is object-oriented as well. So if we come in here, we color code these, that's procedural, object-oriented, 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 object-oriented. So Java and C++ are the same classification of language. So not that. Any other guesses?
Is this just one of those things that like Java does in the background that you were mentioning?
Okay, well, so let's say, I think we're on a decent path with that. But before I answer that, would you say that Java not doing this actually makes it better? Because even though this is a little inconvenient here, isn't there something that's kind of nice about, I mean, especially if you think about some of the things we did last semester when the code started getting very long and you had, 5 or 6 different classes when we were writing like the Dungeons and Dragons thing and stuff like that. Things started getting a little bit out of hand, and to go and find a little piece of code, you had to kind of hunt a little bit, right? So wouldn't you say that even if we had to have a few extra files with these header file type things, it actually kind of acts like an index in a book. It allows you to go and look up what things are in what class without having to sift through all the code. So with that in mind, if it is something that Java took out to quote do it for you, was that a good decision? And that's a whole nother argument. Not all the things that Java does for us, that not all the things that it was trying to do as a convenience for us translate into value added benefits for us. So some of those things actually hide some pretty important stuff, I think. The short version of this is, Java has a built-in technology called JavaDoc that, when used, which people have to purposely choose to use it. And you've actually seen some of the things for it. So if you remember last semester, if you were writing a method, if you're using Eclipse, for example, or later, I know we just did it at the end with Android Studio, but if you were writing a method that overrode like a parent thing, it would put in that override thing in there for you. Kind of remember those things showing up randomly that Eclipse would just fill in. This is technically one of the JavaDoc directives. And what happens is if you write all your code in Java to have comments before each method that's in JavaDoc format, what that'll allow you to do is it'll allow you to run the JavaDoc command, which will generate something like this. It'll generate documentation like this for you if you spend the time to write JavaDoc formatted comments before your methods and fields and stuff like that.
So I got a question.
Sure.
So when you do that, it's creating like documentation for the methods that you are writing, not the methods that already exist in the language.
Correct. It'll generate HTML files inside your folder. So with that in mind, as a developer in Java, especially if you're writing larger projects, it might be in your best interest to use the JavaDoc syntax and spend a little bit more time. So now, instead of spending time writing a header file, you're now spending your time adding JavaDoc syntax inside of your normal file so that you ultimately get a HTML file that is in this format for browsing to see what the capabilities of each of your classes are. All right. So with that in mind, we might say, so we have to use a special syntax within our Java files to allow the JavaDoc program to generate HTML documentation for our code. If we choose to do this, we will end up having automatically generated documentation, kind of like a header file. In HTML format for each class in Java. If we don't choose to do it, we just don't get the documentation. And we might say, well, for smaller projects, that's okay. So we might say that, so in Java, we get to choose whether we think it is appropriate to have documentation generated or run under the assumption that our code is self-documenting. Now, that'll be a funny thing if you want to give Dr. Locklear a hard time about it. This is something him and I have joked about over the years. I'm probably a big advocate of all code is self-documenting. Well, I don't really believe that, but let's say most code is self-documenting. If you name your methods reasonably, you name your variables in meaningful ways, then you don't need to throw a comment after every little line of code saying what it does, because as a programmer, if you look at a variable name and the variable name is string first name, you pretty much know that that variable is built for holding someone's first name. That would be an example of being self-documenting. Where historically, I would say Dr. Locklear likes an abundance of comments. So you might keep that in mind in your software engineering class, that he does like when you verbosely comment your code. I would make the argument of don't just put a comment to put a comment, because then all your comments kind of meld together, as opposed to only commenting when something is actually important. But you might want to clarify what his expectations are related to comments in that class, because I think historically he does like extra comments, where I kind of operate on the other extreme. So kind of a word of warning, but also, a little bit of a funny thing where the mentality of a programmer can be different, where you might spend a lot of time documenting versus spend a lot of time writing code that reads reasonably or something like that. The real truth is probably somewhere in the middle. Probably should write more comments than I write, and probably should write less comments than he expects, something like that. Okay, so I might say, so getting back to your statement about, is this one of those things that Java kind of hides from us? Maybe we give Java the benefit of the doubt and say they technically gave us the option. They said, look, if you care about having documentation, you can follow our Java doc syntax and we can generate it for you. If you don't really care about the documentation for it, either doesn't make sense for your project because the stuff you're writing is self-documenting or not overly, maybe you have 20 different class files, but each file in and of itself is pretty simplistic. You might decide, okay, well, this isn't really worth writing Java doc for. So then you're not also forced to create these extra header files that have 4 lines of code in them that you then duplicate in the other file, which you'll see when we get into that, whether it's next class or next week, depending on how long the virtual machine thing takes, you'll see can get a little tedious. So maybe Java gives us the option. But my experience has been that more times than not, most programmers do not take Java up on that option to use JavaDoc, and instead rely on their classes kind of getting bulked up with a bunch of syntax, and they don't necessarily find it very easy to find stuff. One thing you'll notice in that some IDEs, actually I would say in most, well, let's just leave it at some IDEs, there is a feature to minimize a method where only the header is shown and the implementation is hidden, so that your files end up looking like a header file might look. And let me see if I can show you an example of that. I think, well, I guess I would be surprised if, so here's an example. Like in, this was something from last year or something. So this was kind of like that Dungeons and Dragons type thing in C++. So notice here I have a class called door. Here's my fields. Here's the methods. That's the constructor. And here's 3 methods that I'm going to write. Notice that the implementation is not in the header file. The actual implementation is over here in the CPP file. Notice here I have a sorry, I need to go to door CPP.
So another thing I noticed, it looks like you have to like manually include like the files that you're going to use versus like
Yep.
in Java and like Eclipse, you would just click the button and it would do it automatically for you.
Correct. Yeah, but we'll talk about that once we get into it. But that's a true statement. But notice here that I have to, here's my implementation of the constructor, and I say that this guy belongs to door HPP. Here's my implementation of has direction. This guy belongs to door. Here's my implementation. So, you know, it's a little bit tedious that you write it in the header file first, and then you have to come over here and write it. And one thing that I think is a little bit troublesome with this is that in some more modern compilers for C++, it doesn't actually require you to write those header files. It'll make it work without them, but then that becomes kind of less of the C++ way of doing things. All right, so it's a, I don't know, kind of a catch-22 type situation. So notice here, I think this will do it. Yep. So here in Visual Studio Code, notice I can compress all of these. So now notice that my CPP file pretty much looks like my header file. So because our IDEs have evolved to have little tools like this, now I have code that I can sit here and at a glance, I can look at the CPP file and say, oh, here's the constructor, here's this, here's that. It's like, oh, well, I want to look at the implementation of this, so I can just expand it and look at the implementation. All right, that makes some sense. So somewhere in there, we're going to have kind of that personal preference for things, and you're going to see kind of the different ways of doing things. But I do want you to kind of remember, in the context of programming as a skill set, we kind of do the same things in all these different languages, just some of the languages have traditions, or you know, what was best practices back when that language was popular that maybe makes things more convenient or less convenient, or forces you to do something that you don't think you'll ever use, whatever it is. Just those are the nuances of that language, not the programming stuff itself. All right, questions, comments, concerns, bribes. All right, I will see everybody face to face. Well, most of you, or some of you, face to face on Thursday in S118B. I think we had decided, unless there was a conflict, and we will start off doing our I'll do the virtual machine demo thing so everybody can kind of get their stuff set up. And if you are, if you want to bring your laptop that day, if you live on campus and you're planning on doing this, you can probably follow along with me to get your virtual machine set up using the virtual machine server. I guess I technically haven't tested that with a whole bunch of people doing it at once, but that'll be a fun little experiment. It's supposed to handle that kind of stuff. So if you want to give that a go, show up and we can give that a go. All right, I will see everybody on Thursday. Let's see, were there any important?
See you Thursday.
We want to see the evolution. Jason, that's terrible.
So is this like header document? Is that going to be like a lot